Hiya, this video is about computing the square. Computing square is usual skills to explore the behavior of quadratic functions or solving quadratic equations. Now, usually you can find the proof or verification of computing the square by using the identity for perfect square. But this time I would like to do a little handcraft to illustrate the meaning of computing the square. Now, you can see that I have a piece of paper which is in rectangular shape. And now I would like to make a square. Okay, you know, if you want to make a square, we can say fold the paper in this way. And then let me draw the line here so that you can see the square very clearly. Right here. Okay, the line should be somewhere here. Right. Now then you can see that you have a square here. Now you know the length here, okay, should be a number, right? There should be a value for the length. I'm not going to measure the value for the length here. Maybe I just label it with x. Okay, I know that the length is a certain value, but I am not going to find it. That's why I use x to represent the length of the square. Because it is a square, of course, this length is also x. This is also x, right? Now, I'm going to cut this paper, okay, but I'm not going to cut it as a square. I'm going to say cut it like that. Just throw it anywhere. Okay, cut it. Right. And then you can see that there are actually two figures here. One is the square on the left, and then we have a rectangle on the right. Now, of course, if you look at the size of the rectangle, okay, one length is x because it is the common size for both squares and the rectangle. And the width here, the width of this rectangle, of course, it should be a certain value, but I'm not going to measure it. Let's say it is b. Right. Now, look at this expression again. Can you find any meaning for x squared plus bx, okay, related to this piece of paper? X squared plus bx. X squared, x times x. Okay, actually, x squared is the area of the square. Area is x squared for the square on the left. And for b times x, similarly, okay, if x squared represents the area of the square on the left, then bx is actually the area of the rectangle on the right. Here, it means this area is bx. Now, therefore, in this case, you can see that if I look at an expression like that, x squared plus bx is actually the area of a square and a rectangle. Okay, it means this expression, x squared plus bx, can represent the area of a square and the rectangle. Okay, but for which this square and rectangle share the common side. Now, let me ask you something. Of course, this time now, this paper is a rectangle. I want to make it a square. I want to make it a square by adding something, or by rearranging the paper. you can cut the paper. Now, let me give you an example. Now, of course, if you say put a piece of paper like that, okay, and then cut it here, and then you can probably form a square. But I want to, and then it means this part is the extra paper that I need. But if I just if I don't care about the size, I just want to make an other square, okay, by adding the minimum amount of paper. Okay, how can I do it? You can think about it. It means you can say you can cut the paper and then rearrange the paper, and then you may find that you may need some extra paper so that at the end you get a square. And then I want the amount of extra paper needed to be minimum. Now, let me give you a hint. Okay? Now, what about if I fold this rectangle into half like that? Okay? Then, what is the length of this rectangle? Now, of course, this length is still x, right? How about this one? Do you remember what's the original length for the whole rectangle? This is b. And therefore, if I fold it into half like that, therefore it means this length is half of b, okay, b over 2. Now, if I cut this out, now I have 2 pieces of paper like that. And just remind you, after cutting this part out, this length now becomes b over 2, just half of b. Now, what do you think? Where should I put this piece of paper? Should I put it here again or anywhere? It is not difficult, I think, because this length is x here. It seems it is not bad if I put it here, right? Then I form another polygon, okay? And the area is just the same because I'm using the same piece of paper, okay? The area is just the same as this one before cutting, right? It means if I cut this part out, if I move this piece of paper here, okay, and then the area of this polygon is still x squared plus bx. Now, you can see that this little corner. Now, what happens if I join this corner? If I extend the lines like that, it means I just need this little part. Now, what happened? What do you think? What is it? Okay, if I have this corner here, okay, if I fill this up, then what is these shapes at the end. Now we can check. Now you can see that this length here, okay, is the width here for this rectangle. Therefore it is b over 2, right? And then this part is still the same, x here, right? Therefore altogether this length is x plus b over 2, right? Now how about the other way around? Now if I look at this part, okay, of course it's the same as this one because this part is a rectangle, b over 2. And then come to this one, this length is x. And therefore from here up to this end, the total length is x plus b over 2. Now then you can see that it means they are the same. This one is a square now. It means I just need this little corner, okay, and then so that I can form another square like that. And then for this little corner, you can see carefully, okay, this part is b over 2, this part is b over 2. It is a small square, okay. It means the area of the blue paper and the area of this small corner together, it is a square, okay. And then it means x squared is the area of this part, bx is the area of these two parts. If I have the area of this small square, okay, it forms a bigger square. And for this bigger square, the size is x plus b over 2. And then the area for this square is square of x plus b over 2. And therefore, this explains why after we have added this number, and this number is half of this coefficient, okay, square of half of this coefficient, and then at the end, okay, we arrive the square of this number, x plus b over 2, okay.